Okay, we get started. So I graded your first phase of the project. It's kind of bipolar. Some students did really well, and some did really poorly. And then a bunch of people didn't hand in anything at all. So I don't know what you're going to do if you don't hand in anything. What I can suggest is look into register for next semester, maybe. Because today is the first day. We have priority registration, so you can register for next semester's course. So if you want to take it again next semester, this is the time to register. There's quite a few people who didn't hand anything at all. So I don't know what the deal is. I just look at it, I have some comments. One is when you do your test, when you do an evaluation on what data structures to use to store your data, right? You need a few data points. You cannot just have 1 point because 1 point won't give you the efficiency, won't give you the big O. Well, the way you can tell is the whole big O is based on trend. When you increase the problem size, how the performance is going to change, or it's going to change at all. If it doesn't change, that means big O is 1. If we change it linearly, then it's n. Then we have log n and then n squared. Okay, it all has to do with change, with the trend. So if you have just one data point, you really cannot tell which one is a better algorithm. The discussion should be surround big O. Okay, that's one thing. Second thing is somebody made an effort knowing that one data point is not enough, so they made a 2. But 2 is not enough either, because when you have a 2, you cannot really have a curve. All you can have is a straight line. So let me show you what I mean. So seems like I need to talk about this a little bit. Okay, so say you have, oh no, let me see if I have Excel. Okay, so here is a Excel chart. You can see this is n or x, if you like. Okay, it goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's linearly, right? It goes from 0 to 10. And then this is n squared. So 0 squared is 0, and 1 squared is 1, 2 squared is 4, 3 squared is 9, right? So if you plot it out, you will have 10 squared is 100. So when you plot it out, this is 0, 1, 2, 3, 4, 5, 6. So it goes like this, right? So you plot out, this is a curve like that, right? So now imagine you only have 2 points. say you have this point 0 and this point that is 1 and is 10 and then the y is 100. When you have this, I don't know if I can draw a line. No, I cannot draw a line. I cannot draw. Okay, if you look at my cursor, if you just have the 2 points, then you can draw a straight line. Okay, if you draw a straight line, the line will be just following my cursor. Okay, then that will be a linear relationship. Okay, it's a straight line. So it's a linear, it's not a curve, it's not parabolic uh, curve, it's not a quadratic. In other words, it's a linear relationship. So 2 points are not going to tell you much. Okay, what you need is you need more points. So I recommend it to have like 10 points if possible, but at least more than 2 and more than 5 before you could actually display the trend. Okay, you see that? Okay, and also quite a few people have the value fluctuates a lot. Okay, it fluctuates like this. And it's very hard to tell when you have things fluctuate that bad. Usually that's because you are not getting you are just taking one particular search or one particular insertion. If you just do one, then there's a fluctuation, obviously, right? Depending on what value you want to insert or what value you want to search. Because after all, it is possible um, even for sequential search, for example, to happen to find the value at the beginning of the array, right? Say the first element of the array is the value you're looking for. So in this case, the sequential search is actually faster than the binary search, because binary search will go to the beginning to find the middle point. Since the value you're looking for is the beginning of the array, the middle point is not going to find it, right? Then you're going to do half of the original array and then do another comparison and another comparison, another comparison. So you have to do quite a few before you can get to the beginning. Okay, so because of that, just one value, one search is not enough. That's why you need to do a lot. They do 10% of randoms. So you have 1,000 data. The problem size is 1,000. So n is 1,000. So you can randomly pick 100 numbers or 100 values from the 1,000 and try to find them. Then you can get an average. And then the curve will be much more smooth. Okay, so just one search, one insertion, one deletion is not enough. So you have to do a few, say 10%. Okay, so that's in terms of data points. 2 few is not good, 1 point definitely not good, 2 points, it can be very misleading and you need a lot more. Okay, of course, the more the better. The more the better. Okay, another thing is when you guys plot out the data, right? You see the x-axis is a 0, 1, 2, 3, 4 is linear, right? Okay, and then what some student did was they plotted out, say 0, 10, okay, which is okay. Then 100, that's not good because if you go 0, 10, 100, 1,000, 10,000, that increase over the x-axis is not linear, right? It's a 10 times. It's a 10 times increase. So that is a 10 raised to number of n. Okay, so the curve will look very, very different. Okay, very different. So I have Let me see what this is. Okay, so I give you an example. Let me see if I have an example here. Okay, here's the example, right? Um, see, right now, this is linear. You know why it's linear? You see, the same distance, for the same distance here is 0 to 200,000, right? 200,000 to 400,000. You see the increase is linear, right? And then this is 600,000. So every gap is 200,000. 200,000, and another 200,000, another 200,000, another 200,000, another 200,000. So if you have something like this, you get this curve. You get this curve, right? It looks like this. Okay. Now, if I want to show you, I will change the x-axis now, just to show you what it looks like. Okay. So you're going to change the axis to logarithmic scale. Okay, so that means this is no longer 0 to 20,000, 400,000. Look, I'm going to check it here. Now, see, it's 0 to 10 to 100 to 1,000, 10,000, 10,000, 100,000, a million. So now the curve becomes straight line. Okay, so just by looking at the curves, not enough, not good enough. It doesn't tell you anything. It has to do with the scale of the two axes. Okay, if you is a straight line and then scales or linear for x and y, then that's really linear. But if one of them or both of them are log, then that's a logarithmic relationship. It's no longer linear. Like this one looks like a linear because it's a straight line, but it's not because the axis increase so much faster. Same distance. This is going from 0 to 9, so this increase of 9, say a 10 or 9. And then from here to this is increase same distance, this width, right? Now it's increase 99, not 9. And from here to here is 900, is 900. You see, the rate of increase is much faster. That's why it's logarithmic. Okay, the base is 10. Okay, so it will give you this illusion that this is a linear relationship. The big O is n. This is not. It's not. Okay, so that's one example. So it all has to do with the scale. So I saw people putting this kind of scale. You see, 1, 10, 100,000, 100,000, and you get something like this. That's logarithmic. That's not linear. Okay, and also you like to have more data points again to really show the trend. Okay, so that's one thing. Another thing is, when I read your code and read your writing discussions, um, some of you probably should pay a little bit of attention to your writing. I know we're computer science. I know you're computer science, but I think you should really read your writing and at least you should not have typos. Um, because when you write it in Eclipse, I don't think it has a spell check. You may not have a spell check. So because of that, so you gotta be more careful. Or what you can do is you can write it in Word or with a word processor that has spell check. And then when you're done, then you copy paste into Eclipse. Or just attach as a PDF file, that's fine too. Okay, many of you did a PDF file, that's fine. So, and also a grammatic error, there's a lot of those. So I think, I really never talked about this before, but I think you should pay attention to that, right? That's your brand. That's your brand. How you write is your brand. Because people, when they haven't met you, they make all the judgment on how you write, right? They try to figure out who you are, how much education you had, um, by what kind of person you are, by reading your writing. So I think some of you should be really careful. Okay, if you write nicely, it's very different than write poorly. So it's not just for this exercise; it's for everything. Okay, it is true. It's for everything. Okay, when you're looking for a job, you're looking for internship positions, you really should pay attention. Okay, this is so important. I don't know how I can um, emphasize it to draw your attention. Okay, so some of you may want to maybe even take a course, writing course, maybe, or go on YouTube, watch some videos, see how to write, okay, how to organize your thought. I think that's something some of you should really be careful. I wrote some comments, um, but this is not a writing course, so I just want you to know that be careful, be careful. That's more important than everything else, um, right? If you cannot communicate, if you cannot write, and if you are careless, you show a lot of typos, a lot of grammatic errors. This just shows you don't have a good education, so you can leave a bad impression on people. So I think you should be careful with that. Try to write something nice. Write a story. Write something. Write essays. Um, you know, write your personal story and life experience. And I think that's fun, and it will train you. So I notice people who had a degree before here tend to write a lot better. Okay, I don't know where that stage, what happened. Say if someone got a bachelor's degree before this, they tend to write a lot better, a lot more mature than people who didn't. But I don't understand that what happened. Is it because those schools had a more strict training, more rigorous training for writing, or those people are better to begin with? I don't really know. So I really want to draw your attention to this issue. Okay, write carefully, write with substance, organize logically. At least definitely should not have typos, should not have grammatic errors. Um, some of you may want to sit down with someone who can help you. I know every library I know they have a free tutoring program, so you can ask them. They can hook you up with someone. The person will read with you, will write with you, and then you can give your writing for them to critique, so they can help you revise. You just have to do this a few times, then you'll get better. Okay, people just have to point out to you what's not right, then I think you'll be much better. Okay, another thing is many of you um, did not talk about the data, did not generate the data when you decide upon what data structures to use. This is something I spoke about before. I said the whole exercise, okay, is for you to understand when there is a problem, when there is a task, when you have to make a decision, okay, you should rely on data, right? So you cannot just tell me something that you already learned in general, like a tree is log n, and linked list is n. And this itself is useless, right? There's nothing, there's no value to it, right? So when you write your discussion, you have to support your conclusion with data, okay? With the data, ideally have tables, has graphs, figures, and then has like a discussion, and then from the discussion you draw conclusion. Okay, so I think it's important. You should not just write in general. You pick this data structure because it has log n, right? So that's not enough. That's just the pure 218. At this stage, this one, I want to kind of train you to help you to transition from 218 to the real world, in which case things are all different. So you need to you have different algorithms. You still have to assess them, but there's no easy formula for you to decide what it is, what is a big O. And by going through this kind of dummy data and then run through the test that and plot out the results, and then that will tell you what the efficiency is, what the big O is. So you cannot really just talk about efficiency without talking about data, without talking about your contribution. Okay, for this type of data you have your at hand. So okay, so I think that's it. So what I can tell you is from the data, it looks like the tree set or tree map would be good for user profiles and trails. Okay, and then it seems from a lot of testing, it seems like if you do a tree map and use a username to as the key and the user object as the value, and that's slightly more efficient than general tree set. Okay, but when you do the trails, when you do trails, then you do not have a unique key, right? Because I said even the trail names may not even unique, may not be even unique, because possibly the different trails have the same name. Okay, in that case, you may either generate an ID for each trail and use the ID as the key, like a unique ID as a key, or just use a tree set. In this case, even though tree trails can have same names or same everything, but because it's a new object, it will be treated as a new object, so it won't be considered as a duplicate in the tree set. So that can still be unique. Okay, but the difference should not be tremendous between tree set or tree map. Okay, now for the history, most of you decided to use a linked list. That's fine. The linked list is fine because it maintains the order of the hiking history, right? Which one gets done first, which one did first and second, so on and so forth. Now, there are people talking about using a queue for the history. Now, problem with that is queue has the property of first in, first out, right? That's very good, right? Because that does maintain the order, right? First in, first out, last in, last out. So it does maintain the order, which is good. However, a queue only exposes the two ends of the data structure. Okay, either you can say the head and tail, or the front and rear. So either front or rear, or head or tail, right? So there's only two ends of the data structure are exposed, then you can access. In other words, if you want to do a search, a queue is impossible. I don't know if you can see that, because queues don't allow you to go to the middle of data structure to find or search for a particular trail or particular history event. So queue is not a good idea, right? But linked list allows you to go in there to search, but queue won't. Okay, the whole purpose of a queue is to purposefully limit access to the middle of the data items, only expose two ends. You remove from the head, you add to the tail. Okay, or add to the rear, and you move from the front, however you want to say it. But you can never go to the middle and try to find out what's in between the head and tail, between the rear and the front. Okay, so that's not good. And then a priority queue is not a good idea either, because a priority queue essentially is just sorting your data points by priority. Okay, you don't want to sort them unless you want to sort them by date. Okay, but then there's no point. You can just use a linked list, so you don't have to even sort it. Okay, because that maintains a natural order. So priority queue is not a good idea either. So a number of you decided to use a priority queue. Since hopefully you haven't started truly finish the implementation, so I don't want you get that into your final version of the project, because that's not a good idea. Okay, so assuming at this point you lost it and then you're off the train, you're not with us anymore. Now this little introduction is kind of give you an opportunity to get back on the train, so you know what's the right thing to do. Okay, of course there are people who still using array list. That I said that they want no array list. No array list. This is the data structure you have to assess the best one for your data items. So you should not use array list automatically. Okay, you should evaluate what's the best one. Okay, and then there are quite a few guys still talking about hash map and hash set. Okay, hash map and hash sets are depending on hashing. Okay, the bottom line of hashing is a hash table. And hashing gives a big O of 1. Okay, why is that? Because hashing manages to convert the data items into an array index. That's why you can access the data so fast, because you know where exactly the data is stored in the array, right? Because data is converted, another word for it is hashed into another version, which in this case is an integer. We use that integer as the index of the array. So anything has to do with the hashing is based on array. Okay, you may use a different hash function to turn the data into an integer value, but the underlying data structure is still an array. Because it's an array, then you need to know how many data items ahead of time. Otherwise, you don't know how big array you should create. But I said initially that I made it clear that you do not know. You do not know how many users, you do not know how many trails, right? So because of that, it's not a good idea, because if you do pick a hash map, some of you did, or hash set, then when you create the data structure, you don't know how big the table should be, the hash table should be, or in other words, you don't know how big the array should be, right? So some of you do not put a value, still using hash table. If you don't put a value in the argument of a hash map, what happens is you will give the Java will give you a very small number. And then when you reach that value, right, then you're going to be rehashing. What's going to happen is you're going to create a larger array, and it will take all the data items from the previous hash table and rehashing, re-put them into the bigger array. So all the calculation has to be redone. Okay, then you will have more room now since it's a new array. So when that array is full, and you still want to put more data into it, then you're going to be expanded, doubled again. The table has to be doubled. Then all the data has to be retrieved from the old hash table and rehashed through the hash function, and recalculate the index of the array because it's a different array now, right? And put them back into the new array. So that's very expensive. That's why when some of you did a hash table, the result, the time spent is not one. It's not a flat line. It's not a flat line, right? Immediately that should draw your attention. You say, how is that possible? Hash table should give me one, but it's not. I'm getting something like a linear or something crazily more expensive, less efficient than log n, right? So you know that's not right. Then you should look into it and see what's wrong with it. How is it possible you have a hash function, hash map, turns out to be like n or n log n, and you know, you submit that to me, then you shouldn't, because you should know that's not possible. Something is wrong. So I looked at the code, I realized that's what happened. So when you create a hash map, right? Like hash map, my hash map equals a new hash map, right? There you have to, this is a parentheses. When you create an object, you're gonna have to put a value in there. If you don't put a value, the value will be like 10 and 15. So now I ask you to put 100,000, different data items in there. So how many times you gonna rehash to get to that point then big enough to hold that many data items? That's why the efficiency looks so bad. Okay, so but if you do know your total data item is 100,000, if you do know that for a fact, then that's fine. It's just the hash map, my hash map equals a new hash map parentheses 100,000. Then you know to get go, it will create an array 100,000 or 200,000 to hold your data items, because it's try to maintain a load factor of 0.5 or less to give you that efficiency. Because if you don't have that kind of load factor, then you can have collisions. When you get approach to the load factor of 1, right, then you're going to slow down the big O of 1 tremendously. You're not going to get a big O of 1 anymore, because it's very hard to find an open slot to insert that value, right? And if you have, say, a load factor equals 1 or really close to 1, the whole thing collapses. The whole big O collapses for a hash map. So the API avoids that. So that's why when it gets closer, it will create a new array and then will double hash get all the data out from that smaller, older array, and move all the data into a larger and bigger array, right? So that's why. But by doing that, it takes time because every single data item has to be recalculated, rehashed, going through the function, and inserted into the new array. Okay, so when you see that, when you see your big O is not 1 for hash map or hash set, then you should not, you should not, you should have to find, you should find out why. Okay, you should find out why. I guess that's, and plus we already talked about that. We don't know how many users, we don't know how many trails. So that whole thing should be out of the question. You should not use hashing at all. You want a data structure that's more flexible, that knows to dynamically expand if necessary, okay? Then leave us with, you know, linked list, tree set, tree map, not many, right, left. Array is no longer an option either. What about array list? That's not an option because array list is also based on array. It's just a sugar-coated array, okay? But it is array, nevertheless. Okay, good. So if you're off the train, hopefully this little discussion will help you get back to the train. I don't want to get you deep into something using array for the project and deep into using array list for this project, then realize, this is not right, right? Wasting all the time. Okay, good. Okay. You may want to try to do it, try to do it again yourself, see if you could do it. It's an exercise. Some of you may not be excited because this course is not as much coding as before. A lot of you guys enjoy coding, I can see that, but this is not, right? This, you have to get used to this. Coding part is easy. Okay, figure out how to code, what to code. That's more important. Make the right decision is more important. That's why to some of you, maybe this is boring, but trust me, this is a very important experience because I gave you something new. You have no idea. And now give you a chance to test them, make a decision, make an argument, generate data, and then support your conclusion. So this is going to happen again and again and again in the rest of your career. So you need to know that's the process. And also how to plot your data. Once you have the data, how to plot it, right? What's used for x-axis, what is used for y-axis, how to plot it to show that curve, if it is curve, or that line, if it is a straight line, okay? Because that people look at that, people can tell what a big O is, right? If you have only one data point or two data points, that's not good, right? Good. And if your values are fluctuating all over the place, that means you are just getting some kind of abnormality. You're not getting the average performance. You may hitting the best case scenario or the worst case scenario. You're not getting the average case scenario. So that part is something you should be aware of. And then the scale of the x-axis and y-axis, that's also very important. I just showed you by changing the scale, same data, same value, just changing the way you plot it will make a huge difference, right? Make a huge difference. So you should be careful with that, okay? Okay, so that's that. Any question on that? Okay, that counts for 1/3. Is a very important 1/3 of your final grade. Why is that? Because if you did the right assessment, you're not using array list. Instead, you use a tree set or tree map or linked list. All the code is already there for you to implement your stuff. The coding part is already largely done, finished. Okay, you may need to make a small changes, adjustment, but it's there. Okay, but if you were doing arrays, now in order to implement the second leg of the project, then you're gonna have to recode just about everything because it's not an array. You should not use array. You should not use array list. Okay, I think I wrote an email before the semester started that forget about array list. Just don't stay away from it. Okay, you should never use array list. Right? It doesn't give you anything other than convenience. It's really just an array. Give you convenience because it's sugar coated. You don't have to worry about indices. You just have to worry about the method like add, remove, contains, set, get. So you don't have to worry about indices. But when you use an array, then you have to worry about, but that's how you actually know data gets stored, right? So that's more test more understanding of the data structure rather than hiding um, behind the array list. All right.
Would you be able to show like one of at least somebody who got a good grades portion so I can at least see more of a what you would desire from it exactly? Because I hear I got everything you were saying, but just to actually visualize it and like see it would be like pretty good.
Okay. So I can well I have to ask students permission to show you the work, but it's actually very straightforward. Okay, so you need many data points. Okay, say you have 1,000, 2,000, 3,000, 4,000, 5,000, 60,000, 7,000, whatever values. So ideally, you have like 10 points. Okay, and then so that you have different amounts of data, and then you do 1/10 of search. So you'll grab 1/10 of data from the data structure, and then you do search, you do remove, and you do insertion. But your emphasis should really put into more like in search because you don't remove, you don't add nearly as much, right? So really the decision should be based on searching, not on insertion and deletion, because those are not that important. Okay, right? Then you say, hey, why don't I just do binary search? What's wrong with that? Why you cannot just do binary search? Binary search give you log n, right? That's pretty good. Same as a tree set or tree map. If you emphasize searching is the importance of searching, then why don't we just do searching using binary search? Why is it not a great idea? Why is it not a good idea? Because binary search is based on sorted array. An array defeat the purpose, right? Because we cannot use an array. We don't know how many data items is going to be. Okay, that shows you that binary search is not a good idea. Okay, then you're going to evaluate how much time it takes to search 100 values in a data structure with 1,000 data items, and then you average the amount of the time, and you get an average time for a search. And then you have another data point that's a 2,000 data points, 2,000 trails or 2,000 users, and then you'll search 2,000 random values and see how much time will take in average. So you will get the values pretty that's like an average case, not like a best case scenario, not a worst case scenario. And then when you plot them, the curve will look nicer, much smoother than like a zigzag, like fluctuate up and down like crazy, right? I think I explained that. So if you have that value, so you plot them out, then you would plot them linearly and just see what happens. So you have 1,000, 2,000, say this is 1,000 data items, this is 2,000, and this is 3,000, and this is 4,000, and then this is 5,000, and this is 6,000, say. So you just have this many. And then out of this, you're going to test searching 100 values, random values, searching 200 random values, searching 300 random values, or 400. Or even if you just do 10, like 10,000, I mean, 100, I'm sorry, 100 from here, 110, right? Or 100. You do 100 from here, even 100 from here, 100 from here, 100 here, 100 is fine. You will see the curve is much more smoother than just searching for one value. When you search for one value, depending on which value, it make a bigger difference. Okay, so then you get the average time it takes, then you plot them out. Then you can tell what the curve looks like. Then you can draw a conclusion. It should be like a log n. It should be something log n. So I can do you some log n here. Um, so let's say I have so let's say why don't I do this? I have 1,000, and then say I'm gonna equals log, okay, and log this value, and then base 2. Say I'm gonna calculate this is the value 9.9. Okay, and I'm gonna copy this and paste over here. Okay, now you see as the data item increase so fast from 1,000, 2,000, 3,000, right? The increase of the time is very slow. 9.9, 10.9, 11.5, 12, 12.28, 12.55. You see how flat this is? So if I copy this to the 3 columns, let me copy them, and then paste them over here. Okay, let me paste them over here. I don't need this. Okay, so I'm going to delete this. Now I'm going to plot this out. Okay, I'm going to plot this out and plot into, fine, this is plot into here. And you see this is log n. This, when you increase this so fast, but linearly, you see the increase of the time is very slow. You see this? That's log n. It's very slow. How slow is log n slow? It's very slow. That means if you have 1,000 trails, it will take, say, 9.9 nanoseconds. If you increase to 6,000 trails, you only increase like 3,000, less than 3 nanoseconds more. Okay, it's like 12.55 versus 10. So there's a slight increase over time. So that's the benefit of this. Okay, versus something something that is linear. Okay, so linear will be something equally fast. So if I copy this, I show you, I copy this, I put it into here. Okay, I'm going to change this to, I don't know, say 1, 2, 3, 4, 5, 6, 6. Okay, so if I graph this, right? If I graph this, and you will see it looks like this. That's a straight line. So you linearly increase when your sample size increases or the problem size increases, the amount of time increase linearly, directly proportionally. So that is n. That's n. Okay. Now, if there's no difference, okay, so if I copy this and paste it into here, and then when I increase the size of data structure, so the 1,000 trails is 1, 2,000 trails is 1, and 3,000 trails is also 1, 4,000 is 1, 5,000 is 1, 6,000 is 1. They're all 1. In other words, when you increase the size of the data structure, when you put more data items in, the problem size increases. And then there's no change in the amount of time it takes. So when you plot it, you're plot like that. It's a flat line, straight line, no change, no fluctuation. That's 1. That's 1. Okay. So that means it's insensitive to the problem size. Okay. Now, if I have something that is something like, if the problem is 1, 2, 3, 4, 5, 6, and then the data is n squared, right? So that's n squared is equals this one times this one. Okay, so that's 1. Great. Then I'm going to copy that and paste into here. That's going to be n squared. Okay, so 1, 2 times 2 is 4, 3 times 3 is 9. Okay, that's n squared. This is n squared, right? So if I plot this, and you will see that it will look like this. You see, you look like this. It's a parabolic, goes like this. It's a curve, it's a quadratic. But now imagine you only have 3 data points. It's very hard to tell. Even this one is kind of hard to tell, right? The more numbers you have, the easier to tell. So if I delete this, I'm sorry, if I delete this, let me do another one. So I will give you actually a better idea. So I'm going to copy this and I'm going to paste over here. Now I'm going to increase this 7, 8, oh shoot, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right, so I have more data points now. See, I'm testing 20 data items, okay, data points. So now I'm going to do a insert and it look like that. See, if I even give it a curve, you see, that's not a straight line. It's more obvious now. It's not a straight line. How can you tell? Because we have more data points to show to build up that curve. Imagine now you use only 2 data points, you'll miss the picture, right? If it's just 2 data points, you're not going to see the curve. Does it make sense? So that's quadratic. That's quadratic, right? You see, it goes up slowly. When you increase the data, you slowly then speed up the increase. You see, that's the value. See, 3 and 9, 4 and 16, very slow increase initially. But then 20 is 400. 19, the difference is 1 here, but the difference here is 39, right? So, right? So that is the idea. Now, if I change this, if I change the scale, let me see if I can change the scale. That's a scale. And if I change it to here, where's the place I can change my scale? I don't know how am I changing the scale. This is correct. I think it's no, that's not field, that's not line. This place, shadow. Axis options, logarithmic. So I'm going to change the y-axis to log. Okay. Right now it's linear. You see, gives you something like this. That tells you how important scale, what scale you use on x-axis and y-axis. The shape of the curve will look very different, right? So when you plot your curves, you have to be careful because it's going to have a different effect, a different visual effect. All right, so and the most important thing is when you do your discussion, you should have data to support your conclusion. You cannot just tell me, what you believe. Many people write, I believe this is the better choice, without giving any data to support your belief. That doesn't mean anything if you have no data to support your argument or your claim. Okay. So hopefully by doing this exercise, you understand that doesn't matter what kind of work you do in the future, right? What kind of data structure, what kind of algorithm, you have to be able to convince yourself this is a good choice by doing something like feeding them data just to see how this performance change through the increase of the data size or problem size. Then once you have that, you are solid. You'll win every single argument because you have data. Okay. So this course is not about writing code. I know some of you so eager. Some of you had no discussion, just finish the whole project using array list or using array. But that's so 148. It works, yeah, but that's not the point. So you have to understand the focus is different this time. It's not just the program that works, that's 148 or 118. Okay, the focus is how to make argument, how to make a decision, how to do critical thinking, right? How to propose a hypothesis and then evaluate the hypotheses and falsify your hypotheses. So that's the idea. So I see some of you are struggling, but I don't really understand. In my mind, it doesn't seem like this is so difficult because I wrote some code for you to test. I wrote some code for, I think it was a tree set for users, I believe, right? I use the API, I use the stream. So you just kind of need to replicate that fill in blanks. Ideally, this exercise will allow you to try tree set, tree map, and linked list. So you get to know intimately all three data structures and their APIs. Just for the sake of learning the APIs. All right. Good. All right. Any other questions? It is a serious undertaking. Okay, don't overlook it. Don't think you just need to write a program. It's not. It's a serious undertaking. Yeah, it's different than like you learn solve a like a quadratic equation. It's not just that. Right? That's just the exercise. This is no longer a general exercise. It's to teach you how to think, how to do critical thinking, how to have a problem, how to assess it, and how to make a decision, and support a decision with the data. That's what it's about. So don't jump the gun. Don't try to just write a program using arrays. Okay, I'm done. I don't care about whether how many data items. I don't know. I don't care. I make it a million. Okay, but that's not the point. It works, yes, but that's not the point. Okay, so you have to change the mentality. Okay, this is more about you think things on your own for yourself. Um, other questions? Are you guys okay? Some of you are great, doing fabulously, but some of you are not. Some of you don't even show up. So I don't know what the deal is because I don't think it's that hard. I think probably you guys are slack off, to be honest. But I don't know how I can talk you back into this. It's just different. You have to think more this time rather than code more. Okay. So another thing I heard was that there wasn't enough interaction among students or in the class. And I didn't know that. I thought we had a Discord and then there are some activities there, I assume, but if it's not, there are a bunch of people who are willing to come back. They graduated, they're willing to come back and help you guys. Do you think that would be helpful if I invite them in so you can, or you just don't care? If you don't care, it doesn't matter, we have other people to help you or not. Do you feel that is something be helpful? Do you feel like you want to talk to them if there's such a person, or there are also such people out there? Does any comments on what do you think the problem is? It's like pulling teeth. We're postponing the deadlines all the time and then still not get things done. I can tell you, this semester we have two CSE 218s. So we have a lot of students, and then we only have one CSE 248 next semester. So if you intend to retake this, you may want to register now to take a spot. Okay, because today is the first day. I'm sure you are more senior than most of those people who are into 18, so you can get in and then take a spot. And if you want to stay until the end, that's fine. But you may want to take a spot. What if there's no more seats left? Our school cut a lot of sections because we're down 8%. Actually, we are one of the best schools only down 80% enrollment. Other schools common 10, 20, 25%, 30% sometimes. Crazy. So even our program is growing. We're having more and more students, but our school has like a one policy and we cut sections. It doesn't care what a major, they just cut sections. So we got to cut 2 or 3 sections to save money. So that means, if you want to retake, you're gonna have to register as soon as you can. And also think about, this is something you want to do. You're so close. Some of you I know, you did 148, 218, and then I hate to see you give up at this point. You're so close. Just finish this, do whatever you got to do, and then decide what you want to do afterwards. Either transfer or you go out and get a job without going to a 4-year school, or transfer to a 4-year school, or go to graduate school. It's not uncommon, if you have a degree and then not go get another degree. Actually, very common that people just go get a job. So think about this, right? If you have good idea, what I can do to help you guys out, I will do it, but I just have to know. Okay, I wrote a code, I explained, and I did whatever I can, and I give you enough time. This time I learned a lesson, so the next leg, I asked you for a progress report every 4 days. I need a burn down chart. I don't know if you look at the assignment. Okay, so the deadline is a week from the 1 week from Monday, I think, or to Wednesday this week. So we're about 10 days. And so every 4 days, you should submit a burn down chart. So this way I know how much progress you made. You got to submit the storylines as well. So I was hoping that I would give you a little pressure, but I don't know if it will have any effect if you are committed not to do anything. But I do want to say that don't give up. Don't give up. You're so close. You're so close. At least finish, get an associate degree, at least if you're not transferring. That's going to help you. Okay. Try get out of that hole. I think some of you are in the hole. I think just not do it, not cannot do it. It's just like stuck in a hole. Dig yourself out. Okay, finish it up. Don't give up.
I saw that you posted the final like portion of like the hiking thing, but it only really describes like the burn down chart and everything. Like, what did you want as the final product? Because I understand you want everything for this to show the big O notification, big O notation for everything.
No, that's over. That's
Yeah.
over. So what I need next is sorry. What I need next is let me pull out the 248 and then I pull up the project. I think I post this that has all the description due the 18th, so roughly 10 days. Today's the 9th, okay? So you don't really have a lot of time. And then I ask you every 4 days, I think the next 2 days maybe, you should submit. And then this time I close the Dropbox. That means if you don't submit in time, then you cannot submit. I'm doing my best, trying to annoy you, trying to draw your attention, but I'm doing my best. So, so this way I can monitor. I wrote this. Did you see this? So you're going to implement the whole entire project because so far you already know what data structure to use, right? You already did the planning. You did your diagrams. You need to know. You do know what the classes you need, what the methods you need. You know how they interact. Then now you're going to develop a master story list. Break down the whole entire project into smaller components, smaller tasks using the agile development approach. Okay, and then you have a specific task, and then you also have to put down the amount of effort for each task, 2 hours, 5 hours, 10 hours, what it is, whatever, add them up. And then knowing the deadline is the 18th, then you can divide that and see how many hours you can put in every day. Then you know how many days you need. And then see if you can finish it on time. If you cannot finish it on time, that means you need to put in more hours per day. Okay, that's the point. And then you have the burn down chart. Every 4 days you're gonna submit. The next submission is the 10th, tomorrow at midnight. Okay, so that you're gonna submit the master story list and then accompany it with a burn down chart. See how much work you have finished. Then you know percentage wise, have you finished 1/3 of the project, or have you finished 1/3 of the tasks? Okay, and then on the 14th, you have to submit the second version of a burn down chart. That means hopefully you will feel pressure to submit a different burn down chart with more tasks finished rather than submit the same thing. Okay, the final version is the 18th. You can submit up at the end of the day. But the project is before class. The burn down chart is the end of the day. So you can finish the project when you're all done. Then you do the burn down chart, 100% finished. You submit it by the end of the day. And all the Dropbox will close by the deadline. You cannot submit anymore if you don't submit it. So I warn you now. Okay, so, and then you have to do the implementation. So this is an example of a master story list, and this is an example of a burn down chart. Okay, you can use Excel to do it, you can use whatever to do it, but in the end, if you could, save it as a PDF and submit it, put it in the Dropbox. I created 3 additional Dropbox for burn down charts and for master story list. Okay, so you know where you are and how much work you finished every time. Okay, and then each task you have to do some JUnit test. You have some code to test your methods. You have to write documentation for some major classes and methods. You have to do Java code, obviously, but the Java code is largely done, largely finished, or half finished. Because what you did when you do the evaluation of data structures, you already did the most part of it, if you did it right. But if you use array or array list, that means none of this helps. And you cannot do it again. That's 148. Okay. And then graphic user interface is a separate issue. The most important thing is you have the code so it works even with the GUI if you want. Without a GUI, I mean, with the console, I mean, without a GUI, that's fine. Without that component. So this component is more fluid, more dynamic. So depending on what kind of application you want, then people have a different GUI components. So I would like to separate it into different package. But if you use an MVC, if you use a scene builder, then they can be all baked together. Even the glue you bake into the cake. But do put it into a different package, into like a called view. In other words, you can finish them all at once or each task with GUI. But if you don't think then if you choose not to do GUI because some of you hate GUI for some reason, I don't know why. If that's the case, then leave GUI alone until the end when you finish everything else. So at least on the console, the program works. Everything gets tested. Or the search works, insertion, deletion, creating user account, login, all work. Display the history, display, people can add hiking events, add trails, add the data. Even the routes, the stops, you can wait for that. You either do it or not do it. I don't mind if you don't do it. Because what I want to do now is at least get you guys finished. So you can finish the whole thing, you can graduate. I don't want to keep you guys here for another semester. But if you force me to keep you, then I'm going to have to keep you. I may not even have a seat for you next semester. So I give you the opportunity to finish it without the stops, without the graphs. Just finish it. Finish one thing. This way I can pass you. But you should read this, and if there's a question, you should ask. Okay, so when I grade it, I even tell you, based on the 4 modules, user module on its own should work. That's agile. I don't care about the entire project. The user module on its own can be independent, freestanding. And then the history module, the trail module, and then the GUI module if you want to, if you decide to do GUI. So that's 1/4 of your grade if you don't have a GUI. Don't get hung up with the GUI, then you don't finish one module. Because a lot of people hate GUI for whatever reason, I don't understand. The GUI is so simple this time. You don't have much to do. So every time people fail the test, they say, oh, I hate the GUI. GUI, I spend all my time on GUI part. I cannot do it. For whatever reason, I don't understand. So now I make a GUI like the final thing. If you don't do GUI, you still have a 75 and you can still finish. You still graduate. You get a C plus. You won't get a 0. Right? Now you cannot tell me that because of GUI, you get a 0. Because you don't have to have a GUI. I'm trying very hard, trying to finish so you guys can move on with your life. It's not like I don't like you to be here next semester. I like every one of you. Yeah, you guys are nice. But some of you just not doing it. That's not good. Okay, Janio, you have a question?
Yes. For the board down chart, I thought that was the same as the master list thing.
Master
So like
list is what kind of task you have. The burn down chart is what task you finished. So initially, day 1, 100% effort is still unfinished. So it's high. This is 100%. As you finish your one job, so say out of the 100, you finish 1 day's work, so you're going down here. Then as you finish more, you are going down. So So say 5 days later, you are here. That
Mhm.
tells you how much work left to do. Okay, just by looking at how much, how tall this is. Then you can project how many hours you need every day and when you can finish the whole project for the given deadline.
Okay.
So burn down chart is on the right side, and then the master story list is on the left. I think I wrote it down. I think I said on the left part. Yeah, see? Story list in class and its content is displayed on the left portion of the figure below. So this portion. The burn down chart is the right portion.
So we have to like develop as we go. Let's say I believe it's 4 or 3 charts, like graphs,
Right,
displaying how far we are.
three, yeah. Three of this, one of this,
Okay.
and the three of this. So if you could submit both every time, so I can look at how much you finished, and then if you after 4 days you are still here, that's a bad sign. That means there's so much work left to do. Right? So, but halfway ideally should be here, halfway. See, half of this, halfway. So when you're approaching the deadline, you should be down here, getting close to finish. Make sense? I'm willing to meet with you guys if you need extra help. You just let me know if you want to go over the project and give you more support, more help. I can do that because we don't have a class on Wednesday, by the way, right? Wednesday is Veterans Day. Happy Veterans Day. Is that the right way to say it? Not a Happy Veterans Day. What do you say?
No, I think it is.
It is?
Yeah, I
Okay,
think so.
Yeah, it's usually what I hear.
good. Enjoy your Veterans Day.
I'll do my best too.
So yeah, you can get extra day, Tony, if you're a veteran. Don't take advantage of that.
Just one.
Yeah, that's fine. So now you understand? When I wrote it, I thought you could understand, but obviously not. Okay, ask all your questions. I don't know if I see. Originally, I was planning to show you the scene builder. Okay, I want to give you some examples how to use it and what went wrong last time. I figured out what it was. I was going to upload it, but then I thought I would like to explain to you. So if you want additional help, I can have an additional lecture even just for the project, or whatever you need. I don't know. Because we don't have a class on Wednesday, and if you don't have an objection, I have nothing particular to do on Wednesday. I think Wednesday is a rainy day, I think. So I'd be more than happy to help you guys. Yeah, I think Wednesday is a rainy day. Wednesday, Thursday. To catch up. But it doesn't seem like you guys want to do it. Even to take advantage of that.
I think it'd be cool if you hold something Wednesday and or
Mhm.
Thursday. I think it'd be cool.
Thursday, yeah. Wednesday I'm open. So if
Okay,
you
yeah.
want to do Wednesday, Thursday, then I have class in the morning, whole morning, then class at the night. I have 3 classes.
Alright,
For
so maybe
me,
not Thursday then, but yeah, Wednesday should be fine.
Tuesday is harder, but I have some time in the afternoon, I think. But then Wednesday, because it's the day off, so I have a whole day. So you just have to let me know. I think it's enjoyable. I like this project. Enjoyable. It's not overwhelmingly complicated, right? If it's that complicated, then you lose the sight. Then you get overwhelmed. This is not that bad. Right, so you small enough, you can do a decent job because it's small enough. You don't have to rush. If you feel if you feel like you want the actual lecture on sim builder, I can do it today, even if you want, like this evening, if you want. Because I know some of you may want to actually implement everything, including sim builder and the coding part. So if you want to do that, I can have a lecture tonight or something. So you can show you how to do scene builder, how to change scenes, how to change views. If that's helpful. So today we don't have time. It's 1:58, and I know I have a few students from other classes that need advisement. They're gonna come in at 2:10, 2:15, 2:15. So just let me know if you want to, then I could set it up and announce it to everyone, whoever wants to join, if you have this idea. Because otherwise we're gonna wait a week from today. If you learn Simbuilder at that time, it's kind of late, right? Because it's due on Wednesday.
I think it'd be cool if you do it tonight, depending on the time, because I have a lecture from 6 to 7:50, but usually from like 6 to 7. Or I can just stay after class and talk to you there. Either way, I'm good.
Yeah, I can do 6 to whatever. I don't care.
Well, I have class at 6, so I wouldn't be able to. I can join
7.
after, maybe.
You can join after.
Okay. Same link?
Same what?
Same link? The same Google
Yeah, that's
Meet?
the only link.
Okay, cool.
Yeah, I told people to write a program to keep this link. A
It's
lot of
automatically
people,
saved in your browser. What do you mean?
don't remember this link.
Oh.
They couldn't get in. Then email me waiting outside. Did they forget the link?
I don't know.
All right. So is there enough interest so we can have one tonight at 6 o'clock or 7 o'clock? If you want to join later, I can do it. Even do it at 7. So this way you can all have your dinner. I don't know. You finish it by 7. If not, we can postpone 7:30, and then we can sit down and relax, and then we can go over how to do scene builder, and then we can go as late as you want, 8, 9, 10, whatever. Good. So if you have never done it before, you just need to install it. Okay, install scene builder. Put it into a place that you know where it is. Once you install it, okay, then we'll show you how to use it, how to install it, and how to use it, and how to configure it. It's fun. It's fun. But I know many of you already using it, so it's optional. It's up to you. I just like you to, be a little bit more serious about this and get it finished. Right? Don't give up. Everyone okay? Yeah? Don't give up, okay? This is so close. All right. So any questions? Because I can't really start the sim builder now for the next few minutes. So if you have any other questions, we can talk about it. Do you understand the project? What it needs to do? What do you need to do? The scope of it, right? So that's a third. Then we have an exam in the end. So total of 3 things. First, this is the second. The first one we just graded. This is the second one, and then in the end of semester we have a exam. Then you're gonna write some programs. You all right, guys? No questions? If no questions, you may, if you have questions, you may stay. If you don't want to ask in front of everyone, because I will be here. I know one student has to come in at 2:15 or 2:20, and he brought his parents. I'm not supposed to talk to parents, but a lot of students cannot do anything without the parents. So I'm not even supposed to talk to parents. Cut the umbilical cord. Heard of that? Okay, so I see some of you. I see you tonight, I guess. Otherwise, I see you a week from today. My God.
Professor, when
Yeah.
if you do the sim builder thing today at night, can you send an email for those that are interested can join as well? So that way
Well, we
we
can start
know when it
now.
starts.
I think. Do you want to do 7:30? Is that okay? After
7.
dinner? Do you have other things to do? If you do, we can reschedule to another day, another night. If you don't, then we can do 7:30. Or if you are really interested, you want to attend, but the 7:30 is not good, email me, and then I can reschedule, and I will notify everybody what's the time. Okay. But if you don't receive an email from me, then I would say just 7:30. So I guess that's good time, I think, right? Not too early, not too late. You can finish your dinner and then get a cup of coffee, and then we can go over things, relax. And then if you want to do the same, to go over your project on Wednesday, we can do that too. In other words, Wednesday we can go over whatever question you have on your project. And I don't know, you guys don't seem like you enjoy doing it. It's such an enjoyable project. Kiefer, what do you think? You okay with it? Yeah, I think it's enjoyable. It's different because it's not just coding. So get used to it. And if you want to talk about on Wednesday, we can do that too. But email me, then I can set up time. It's a rainy day. What else are you gonna do? Right? Might as well do something on Wednesday. Okay? Why not? Okay, then I see you then. I see you when I see you. Adios.
Have a good day,
I'm
Professor.
I'm a